understand. Sorry, I can't be of help. Okay.
Oh, sorry. What's going on here?
I think she's trying to say something, but I really don't understand what she's saying.
I get what's going on. She is trying to communicate to you, but you don't understand.
Exactly.
And you're trying to talk to her, but she can't hear you.
Yeah.
Oh, don't worry.
From the screen, you can see the science behind the project and how the system is structured. The app is built around three main rules: doctor, patient, and learner. When doctor is selected, the user is taken to a dedicated interface where the doctor can connect directly to a patient's device and communicate using our specially designed interaction method. The doctor generates a session code which is shared with the patient. Using this code, the patient's device securely joins the session, enabling real-time communication. On the patient side, the session code is used to establish a secure connection. The patient enters the code, and once verified, the session is successfully connected. This enables seamless real-time communication between the doctors and patients' devices, making it suitable for consulting room conversations. Example, a deaf patient walks into the hospital. The doctor greets her warmly and she replies politely, "Thank you." The doctor asks for her hospital car and checks in to see how she is feeling. The patient explains that she's not feeling well. Concerned, the doctor asks what seems to be the problem. The patient describes that she has a severe headache, her body feels hot, and she has a runny nose. The doctor continues the assessment by asking, "Do you feel dizzy?" The patient confirms that she does. "Have you eaten today?" asks the doctor, and the patient replies, "No." "Do you feel tired?" The doctor asks again, and the patient nods in agreement. Carefully noting the symptoms, the doctor advises her, "Based on what you told me, I recommend you go to the lab for a malaria test." After some time, the patient returns with her test results. The doctor reviews the report and informs her, "Your results are ready. You have malaria. Please go to the pharmacy for your medications." Throughout the consultation, the doctor and patient communicate seamlessly through the app, demonstrating how technology can make consultations more accessible, especially for patients with hearing difficulties. We conducted a pilot study of the application at the Ashanti Mampong School for the Deaf. Students demonstrated remarkable enthusiasm throughout their engagement with the system, though, as with any early stage technology, some moments of frustration were observed along the way. Here you can see one of the students interacting with the system directly from their classroom. The overall response from both students and staff was encouraging, reaffirming the real-world need for accessible sign language-based communication tools in Ghanaian healthcare settings. The pilot revealed valuable insights into how deaf students engage with AI-assisted sign language recognition, insights that will directly inform the next phase of development. Moving forward, the feedback gathered will be used to refine the system's accuracy, improve the user experience, and expand the data set to better represent the diversity of Ghanaian Sign Language in clinical contexts. This study marks an important first step toward building a more inclusive healthcare communication bridge for the deaf community in Ghana and beyond.